Example number 3. Beam subjected to a uniformly distributed load. So, dalawang solutions ang gagamitin natin para sa problem na ito. Solution 1 is we apply the area moment. Okay, assume muna tayo ng directions ng reactions. So, about upward. Then, to solve for the reactions in symmetrical, mas mabilis kung gagamitan na lang natin ng vertical equilibrium. So, applying summation forces vertical equal to 0. So, AY upward plus BY, then minus the load downward, then equal to 0. So, since symmetrical, AY is equal to BY. So that AY, which is equal to BY, is equal to WL over 2. Ngayong meron na tayong reactions, ang next step is we draw the moment by parts. Say we choose point A as our reference, so we draw the moment by parts at A. So ang nagkakos ng moment at point A ay yung reaction at B and the uniform load. So due to the reaction at B, the moment by parts diagram is triangular, starting from point B, terminating at A, and the moment is WL over 2 times L, or simply WL square over 2. And due to the uniform load, the diagram is spandrel, second degree. So kapag ang loading natin ay uniform load, yung moment by parts diagram ay second degree, starting from the far end of the uniform load, which is at point B, and terminating at point A, our reference. Okay, and the moment is, the load is W times L, then times its lever arm, L over 2, or simply WL square over 2, negative. Then next is we solve for the area. So for the triangle, the area is 1/2, the base is L, the height is WL square over 2, or simply WL cube over 4. And for the second degree spandrel, the area is 1/3. So kapag second degree, the area is 1/3. The base is L, and the height is WL square over 2, or simply WL cube over 6. The next, we solve for the parameters 6A over L and 6AB over L. So for the parameter AA, area times lever arm from left. So for the triangle, WL cube over 4 times its lever arm, the distance of its centroid from left is 1/3 of L. And then for the spandrel, negative, WL cube over 6 is the area, and times the lever arm, the distance of its centroid from left is 1/4 of L. So kapag second degree, distance from left is L over 4. Okay, then simplify. So AA is equal to WL raised to 4 over 24. And then multiply the result by 6 over L. And simplify. So we obtain WL cube over 4. So yan ang formula for 6A over L ng simple beam subjected to a uniformly distributed load. Then for the parameter AB, area times lever arm from right. So for the triangle, the area is WL cube over 4, and its lever arm from right is 2/3 of L. Then for the spandrel, negative, area is WL cube over 6, and its lever arm from right is 3/4 of L. Then simplify. WL raised to 4 over 24. Multiply the result by 6 over L. And we obtain WL cubed over 4. Okay, solution 2 is we apply integration. So, kuha tayo ng strip. The width of the strip is dx. Then, let's take point A as our reference. Then, from our reference towards the strip, the distance is x. And the differential load is dP, which is equal to W dx. So, ang loading natin ay naging concentrated load with a magnitude of dP equal to W dx. And distance of the concentrated load from left is x. Then, yung distance of the load from right is L minus x. At itong x na to yung ating magiging A. And yung distance sa kanan, L minus x, yun yung ating magiging B. Since ang load natin ay naging concentrated load na, yan, applicable na yung formula for concentrated load. So, for 6A over L, the formula is PA over L, L square minus A square. Okay. So, the load P is W dx. The distance A is x. Then, over L. Then, L square minus A square. Then, since involved ang differential dx, then we integrate. Then, limits kapag si strip ay nasa left, extremities ng ating uniform load ay A and B, no? So, kapag si strip ay nasa A, then the distance of the strip from point A is 0. So, that will be our lower limit. Then, kapag nasa kabilang extremity naman, at point B yung strip, then the distance of point B from our reference A is L. So, the upper limit is L. Actually, sa problem solving, kung after tayo sa numerical value, syempre given yung W, given yung L, so ating pipindutin na lang sa calculator, no? Pero since tayo ay nagdi-derive ng formula, so ipa-perform natin yung manual integration. Pero kung after tayo sa numerical value, we just use our calculator, no? Okay, so simplify, apply manual integration, distribute x, so L square x minus x cube, and then dx. Then integrate L square x square over 2 minus x4 over 4, limits from 0 to L. So substitute the limits. So L, substitute natin sa x. So magiging L square over 2, or simply L raised to 4 over 2. Then minus L, substitute for x. So L raised to 4 over 4. And then 0, substitute sa x. Okay. Then simplify. WL cube over 4. So yan ang ating formula for 6A over L for uniformly distributed load. For 6AB over L, we apply the formula PB over L, L square minus B square. So the load P is W dx. The distance B is L minus x. Then over L, and then L square minus B square. Okay, then integrate. Limits from left to right. So from 0 to L. Then simplify. So L square minus expand. So L square minus 2x, then negative, so plus. So minus 2lx, then negative, so plus 2lx, then minus x square. So cancel. Then dx, then simplify further. Distribute L. So 2lx times L. So 2l square x minus lx square. Then distribute negative x. So minus 2lx square. Then plus x cube. Then simplify further. So 2L square x minus 3 LX square plus x cubed. Then integrate. So L square x square minus LX cube plus x4 over 4, limits 0 to L. Substitute the limits, then simplify. So substitute L for x. So L square times L square is L raised to 4 minus L times L cube is L raised to 4, then plus L raised to 4 over 4. Then simplify. Result is WL cube over 4. So formula for 6AB over L for a beam subjected to a uniformly distributed load is WL cube over 4.